Hi, in this video, I'll be doing the H2 Mathematics 2021 Paper 2. For question 1, they are testing you on your concepts of complex number, and so they give you an equation with real coefficients and they give you one of the roots, and we're supposed to find the other roots and the values of A and B, which are unknown. So one thing you need to remember is if the equation has only real coefficients, it means that the roots have conjugate pairs are also a solution to the equation. What do I mean is the conjugate of this root 1 minus half pi I must also be a root of the equation, because this conjugate roots will then cancel out to become a real factor. So that's what it means. So as long as you know that the coefficients are all real, then the conjugate roots of the equation must also be roots of the original equation. And with that, we can now sub in x equals to 1 plus half I and get so we just sub in and then we solve. Then we get two parts. And with that, then we can, by comparison, we can deduce the values of A and B. And because we already know 1 minus half I is a root, it allows us to write this and this as the root. Then we let R be the other root, which has to be real already. Then we expand inside, which get us what we want, and then we deduce that R equals to minus 4. So it's a lot of algebraic manipulation, but the key idea is you know the other root. So you have these two roots, you just let x minus R be another root. After you found the constants, the values, the unknowns, then you solve for R, which you see that is minus 4. For question 2, it tests you on your understanding of integration as the definite integral being the area under the curve. So what does that mean? Is that, well, the first part is simple. They ask you state the value of h, and h is just the width. So you just take 5 minus 4, then you just count 1, 2, 3, 4, 5. So there are 5 parts. So it's just 4 over 5. As for the sketch of the graph, well, you take the sum of the rectangles, and the rectangles, the height, you can see that this is h and this is f, don't know what, f1 first. So f1 is here, then times h means they are calculating this height, so you just draw it here. And then the next one is f1 plus 4 over 5, so it's over here now. Then it times h, so it times h here, so you just take this rectangle, then you just keep doing it until you got the last one over here, which is here. So you can see that it is less than the area under the curve. It's an underestimation because there's parts of the curve that is not filled. So this is why the sketch shows that the area of the shaded region is the expression that you have, and it has to be less than the area of the under the curve. So this is the basic understanding for integration, and as you have infinite number of rectangles, then it becomes a better and better approximation of the area under the curve. So now we're supposed to find an expression, but now you use the greater than. Well, if you want greater than, then you have to overestimate it. So you just use the height on the right hand side, so the right point, then you just draw, and then it will become overestimation. And now we are given that the curve is 1 over 20 x squared plus 1. And we're supposed to use our expression in part A and part B to find the upper and lower bounds. So that's simple, because now they already give you the fx. You just lower bound it by your earlier and upper bound it by your part B, because this is an overestimation. So this is A. Then just sub in the values, compute the sum, and you'll get this as the answer. So you can just check it out and see whether you're correct. As for part D, they want you to now sketch the curve, but they want the area between the curve is less than this function looking thing. From earlier, we see that if we go from 0 to 4, we use the left hand side, it will be less than. But that's because the curve is increasing. So when we draw it, this part will be higher than the below. So in the likewise idea, we need it now to be decreasing. So we have a decreasing one, then when we draw from the left, it will always overshoot. So it now become bigger. So you can see how it works. This rectangle drawing area under the curve. But if it has infinite number of rectangles, rather then these two upper and lower bound will converge, which will allow us to find A. So it doesn't really matter once we have infinite number of rectangles, which allows us to do integration. But because it's not possible to have infinite, you can just draw a finite number. So it will be either overestimation or underestimation, depending on how you draw them. For part 3, it says it just tests you on your ideas of functions, and we're given a g and h, and we're supposed to find the composite at 2, at x equals to 2. So very simply, gh, you first sub 2 into the function h, then sub that value into g. So just sub into h and you get 5, then you put g5 is 1/4. So gh2 has to be 1/4. And now we're supposed to find the value for which gx is 1.4. So just let this equal to 1.4 and solve for x. So it's 0.4 I mean. And now we have a function which is x plus a over 2x plus b. And we're supposed to give an expression for k and explain why this value of x has to be excluded from the domain. Well, from what we have practiced always, this function will not be defined once the denominator is 0. So k has to be minus b over 2 because that will make this denominator 0. So it has to be excluded, or else the function is not defined at that point. And now we are given that the function is equal to its own inverse, and we're supposed to find the possible values of a and b. Well, if this is the function, we solve it until we write x in terms of y. Then because fx equals to f inverse, that means that this function must equal to the inverse function as well. So this is the inverse function. Then because this is so, we just cross multiply, do some comparison, and we can see that b has to be minus 1. And because of that, we already know b is minus 1. We sub back b is minus 1, and we are able to break down now x plus a over 2x minus 1 into half plus a plus half over 2x minus 1. And to ensure that this condition is still filled, this portion cannot be 0, or else it will be a constant half. So a cannot be minus half. So meaning the possible values of a can be any real number except minus half, and b has to be minus 1. So this one is a little bit more tricky, but if you go through the steps, it should flow rather naturally, that you must first find what is the inverse function and see what can you get out of it, what information. So you just try to get more and more information, and once you have it, then the only value is you must think what values a can take. Then if after realizing a can take multiple values, maybe a cannot take certain values, and so you just try to find a way to see whether you have any conditions on a. And with this it comes experience and practice, so just try out more and more questions from other years. And lastly, now we're supposed to find an expression for f inverse minus 4, and f inverse minus 4 will just be f minus 4, so you just sub in f minus 4 into here, and we already know b is definitely minus 1, so you can just put minus 1 here, then just leave a as a. So that's all for this video. I hope you have enjoyed and learned from it. Feel free to like, share and subscribe, and I'll catch you in the next one. Bye.